Our home planet, a tiny blue marble. Earth feels big to us, it really does. We walk on its surface every day. We drive cars for many hours to cross states or countries. We fly in airplanes for even longer, crossing vast oceans and entire continents. From our human perspective, the Earth is a massive place, a world full of diverse landscapes and seemingly endless horizons. Its mountains tower high, and its oceans plunge deep. This is the scale we naturally understand, the world that shapes our lives and our thoughts about distance and size. It's our home base, our everything. But let's try to get a different perspective on Earth's size. Our planet has a diameter of about 12,742 kilometers, or roughly 7,918 miles. Imagine you could drive a super-fast car around the Earth's equator without stopping for gas or traffic. Even if you drove at 100 kilometers per hour, it would take you more than 400 hours to complete the trip. That's over 16 straight days of driving, day and night. This gives you a sense of its physical dimensions, a sphere of rock and water that we call home, teeming with life. Consider this. The deepest point in our oceans, the Challenger Deep in the Mariana Trench, is about 11 kilometers down. The highest mountain, Mount Everest, is almost 9 kilometers high. These are impressive features to us. They represent extremes of our world. Yet, if Earth were the size of a billiard ball, these features would be almost imperceptible. The Earth would feel incredibly smooth. Its vast oceans would be just a thin film of moisture on that smooth ball. So, while Earth is our whole world, our cradle, it's crucial to understand its place in the bigger picture. In the grand cosmic theater, our planet is but a tiny speck. It's a precious, fragile oasis of life, floating in the immense darkness of space. Recognizing Earth's relative smallness is the very first essential step. It is the first rung on the ladder to comprehending the truly mind-stretching vastness of the universe that surrounds us. It sets the stage for an incredible journey outwards. Now let's zoom out from Earth. Let's venture into our local cosmic neighborhood, the solar system. Our solar system is a gravitationally bound system. It consists of the Sun, our star, at the very center. And then there are 8 planets, including our Earth, that orbit this brilliant star. These planets, along with their moons, asteroids, comets, and dwarf planets, all dance to the Sun's gravitational tune. The spaces between these celestial bodies are vast, far exceeding any distances we commonly experience on Earth. The Sun is the undisputed king of our solar system. It contains more than 99.8% of the total mass of the entire system. Earth is about 150 million kilometers, or 93 million miles, away from the Sun. This distance is so significant that we call it an astronomical unit, or AU. Light, the fastest thing in the universe, travels at about 300,000 kilometers per second. It takes light from the Sun about 8 minutes and 20 seconds to reach Earth. Think about that. If the Sun were to suddenly vanish, we wouldn't know for over 8 minutes. Let's consider other planets. Mars, the red planet, is our next-door neighbor outwards from the Sun. On average, it's about 1.5 AU from the Sun. Jupiter, the giant of our solar system, a massive ball of gas, orbits much farther out, at about 5.2 AU. Light from the Sun takes over 43 minutes to reach Jupiter. And then there's Neptune, the most distant major planet, which is about 30 AU from the Sun. Light needs more than 4 hours to travel from the Sun to Neptune. These are not leisurely strolls. These are immense cosmic gulfs. The solar system doesn't just end with Neptune. Beyond Neptune lies the Kuiper Belt, home to dwarf planets like Pluto. And then, much farther out, the theoretical Oort cloud. The Oort cloud is a spherical shell of icy bodies, thought to be the source of long-period comets. It could extend out to 50,000 AU, or even 100,000 AU, that's almost a light year away, or even more. Our fastest spacecraft would take tens of thousands of years to cross this vast expanse. Our solar system, our immediate cosmic home, is already astonishingly large. Our Sun, the star that gives us life and warmth, is just one star. It's a fairly average, middle-aged star. Nothing particularly special in the grand scheme of things. There are countless other stars out there, spread across the vastness of space. The space between stars is called interstellar space, and the distances involved are many, many times greater than the distances between planets within our solar system. We need a new unit of measurement for these scales, the light year. A light year is the distance that light travels in 1 year. Given that light zips along at approximately 300,000 kilometers, or 186,000 miles per second, a single light year is an enormous distance. It's about 9.5 trillion kilometers, or nearly 6 trillion miles. That's a 9 with 12 zeros after it in kilometers. Try to wrap your head around that number. It's a distance so large it almost loses meaning in our everyday experience. This is the ruler we use for interstellar distances. The nearest star system to our sun is Alpha Centauri. It's actually a triple star system. The closest of these stars, Proxima Centauri, is about 4.24 light-years away. So the light we see from Proxima Centauri tonight left that star over 4 years ago. If something were to happen to Proxima Centauri right now, astronomers on Earth wouldn't know about it for more than 4 years. That's how far away our closest stellar neighbor is. It's not exactly next door. To put this into perspective, if you were to use our fastest current spacecraft, like NASA's Parker Solar Probe at its top speeds, it would still take tens of thousands of years to reach Proxima Centauri. Imagine generations upon generations of humans living and dying on that spacecraft just to reach the very next star system. This illustrates the profound emptiness of interstellar space. Our sun, along with all its planets, is itself moving through this space, journeying within an even larger structure, our galaxy. So our sun is a star and Proxima Centauri is another star, but where are all these stars located? They are part of a colossal structure, a massive city of stars, gas and dust, all bound together by gravity. This stellar city is our home galaxy, the Milky Way. When you look up at a clear, dark night sky far from city lights, you might see a faint, hazy band of light stretching across the heavens. That band is the Milky Way. You're seeing the combined light of billions of distant stars in our own galaxy, viewed from our position within it. The Milky Way is a spiral galaxy. It has a central bulge, composed mostly of older stars, and several spiral arms that curve outwards. These arms are regions where new stars are actively forming. Our sun is located in one of these spiral arms called the Orion Arm, or sometimes the Orion Spur. We are not in the bustling downtown center of the galaxy, nor are we out in the far remote suburbs. We're in a reasonably comfortable, relatively calm part of this vast cosmic metropolis. How big is this galactic city? The Milky Way is estimated to be about 100,000 light-years across. That means it would take light 100,000 years to travel from one edge of the galaxy to the other. Think about that. The light from stars on the far side of our galaxy started its journey when early humans were first emerging on Earth. And how many stars does it contain? Estimates vary, but scientists believe the Milky Way has somewhere between 100 billion and 400 billion stars. Each one of those stars could potentially have its own system of planets. Our solar system is located about 27,000 light-years away from the galactic center, the supermassive black hole known as Sagittarius A*. We, along with all the other stars in the galaxy, are orbiting this center. It takes our sun about 230 million years to complete one orbit around the Milky Way's core. This is sometimes called a galactic year. The last time our solar system was in its current position in the galaxy, dinosaurs roamed the Earth. This gives you a sense of the immense timescales and sizes involved even within our own galaxy. Section 5. Islands of Stars, Other Galaxies. Is our Milky Way galaxy the only one? Is it unique in the cosmos? The answer is a resounding no. Our galaxy, as vast and magnificent as it is just one among countless others. The universe is filled with galaxies, often described as islands of stars separated by vast stretches of intergalactic space. Astronomers estimate that there could be as many as 2 trillion galaxies in the observable universe. Each one of these galaxies is a collection of billions, or even trillions of stars, along with gas, dust, and dark matter. The nearest large spiral galaxy to our own Milky Way is the Andromeda Galaxy, also known by its catalog number M31. Andromeda is about 2.5 million light-years away from us. This means the light we see from Andromeda tonight left that galaxy 2.5 million years ago, long before modern humans existed on Earth. We are literally looking into the past when we observe distant objects. Andromeda is even larger than the Milky Way, perhaps containing as many as 1 trillion stars. It's a beautiful spiral, visible to the naked eye as a faint, fuzzy patch on a dark night. An interesting fact about Andromeda is that it's on a collision course with the Milky Way. Don't worry, it's not happening anytime soon. The two galaxies are hurtling towards each other at a speed of about 110 kilometers per second, or nearly 250,000 miles per hour. They are predicted to collide and merge in about 4.5 billion years. This cosmic smash-up will eventually form a new, larger elliptical galaxy, sometimes nicknamed Milkomeda. Such galactic collisions are common events in the universe, shaping the evolution of galaxies over cosmic time. Galaxies are not just scattered randomly throughout space. They tend to congregate in groups, clusters, and even larger structures called superclusters. Our Milky Way is part of the Local Group, a collection of more than 50 galaxies including Andromeda and several smaller dwarf galaxies. The Local Group itself is part of the Virgo supercluster, a massive agglomeration of thousands of galaxies. And even superclusters are arranged in filamentary structures and great walls, separated by enormous cosmic voids, almost empty regions of space. The scale just keeps expanding layer upon layer. Section 6, the observable universe peering to the edge. So we have planets, solar systems, galaxies, and clusters of galaxies. How far does all this go? What is the full extent of the universe? This brings us to the concept of the observable universe. The universe is thought to have begun with the Big Bang, an event that occurred about 13.8 billion years ago. Since then, the universe has been expanding. Light from distant objects has been traveling towards us through this expanding space. Because light travels at a finite speed, and because the universe has a finite age, there's a limit to how far we can see. We can only observe objects whose light has had enough time to reach us since the beginning of the universe. This defines a sphere around us with Earth at its center. The edge of this sphere is the cosmic horizon, the farthest we can possibly see. Light from beyond this horizon simply hasn't had enough time to travel to us yet. So, the radius of the observable universe is roughly 13.8 billion light-years in every direction we look. However, there's a fascinating twist. While the light from the most distant objects we can see has traveled for 13.8 billion years, the universe itself has been expanding during that entire time. This means that those objects that emitted the light 13.8 billion years ago are now much, much farther away from us. Due to this cosmic expansion, the current proper distance to the edge of the observable universe is estimated to be about 46.5 billion light-years. Therefore, the diameter of the observable universe, the distance from one side to the other passing through Earth, is estimated to be about 93 billion light-years. Try to visualize that. If our Milky Way galaxy, which is 100,000 light-years across, were shrunk down to the size of a small coin, like a US quarter, then the observable universe on that scale would be a sphere with a diameter of roughly 2,300 kilometers, or about 1,400 miles. That's approximately the distance from New York City to Dallas, Texas. A coin representing our entire galaxy in a sphere that vast. Section 7. Cosmic distances, numbers that boggle the mind. Let's pause and try to truly appreciate these cosmic numbers. They are so large that they often feel abstract, almost unreal. A light year, as we've said, is about 9.5 trillion kilometers, 5.9 trillion miles. That's a 95 followed by 11 zeros for kilometers. If you were to count to 1 trillion, saying one number every second without stopping to eat or sleep, it would take you over 31,000 years. And a light year is nearly 10 times that number in kilometers. It's a distance that dwarfs any human experience. Now, consider the number of stars. Our Milky Way galaxy contains, let's say, an average of 200 billion stars. That's 200 billion. If each star were a single grain of fine sand, 200 billion grains of sand would fill a very large dump truck. Now remember, there are an estimated 2 trillion galaxies in the observable universe. If each of those galaxies also has, on average, 200 billion stars, then the total number of stars in the observable universe is truly staggering. It's like having 2 trillion of those large dump trucks, each filled with grains of sand. Here's another comparison often used. The total number of stars in the observable universe is thought to be greater than the total number of grains of sand on all the beaches and in all the deserts on planet Earth. Every single tiny grain of sand you've ever seen or could ever imagine on Earth, multiply that many times over, and you start to approach the number of stars out there. Each one a potential sun, many with potential planets. The sheer quantity is overwhelming. These analogies help us to get a slight mental foothold on these immense quantities and distances, but ultimately our human intuition, shaped by life on a small planet, struggles to fully grasp the true scale of the cosmos. Our brains simply didn't evolve to deal with numbers this large or spaces this vast. We rely on mathematics and the tools of science to be our guides. They allow us to explore these realms intellectually, even if we can't physically travel there or emotionally comprehend their full immensity. Section 8. Beyond the Horizon. The Unseen Universe and Its Mysteries. What lies beyond the edge of our observable universe? The simple, honest answer is, we don't know for sure. The observable universe is defined by the distance light has been able to travel to us since the Big Bang. It's highly probable that the universe continues far beyond what we can currently see. It could be vastly larger, perhaps even infinitely large. Our current view is like being on a ship in the middle of an ocean. We can see to our horizon, but we know the ocean continues beyond it. Cosmologists have various theories about the overall shape and total size of the universe. Current observations suggest the universe is flat on large scales, meaning that standard Euclidean geometry applies. If it's perfectly flat and extends infinitely, then the universe is indeed infinite in size. However, it could also be very, very large but finite, perhaps curved back on itself like the surface of an enormous four-dimensional sphere or torus. Discovering the true geometry and extent of the entire universe is one of the biggest challenges in modern cosmology. Adding to the mystery is the fact that the stuff we can see, stars, galaxies, gas, and dust, which is made of atoms, only accounts for about 5% of the total mass and energy content of the universe. The rest is made up of two enigmatic components, dark matter and dark energy. Dark matter, making up about 27% of the universe, doesn't emit, absorb, or reflect light, but its gravitational effects are observable in the rotation of galaxies and the structure of galaxy clusters. We know it's there, but we don't know what it is. Then there's dark energy, which accounts for about 68% of the universe. This mysterious force seems to be causing the expansion of the universe to accelerate. It acts like a kind of anti-gravity pushing space apart. Its nature is one of the deepest puzzles in physics. Some theories even propose the existence of a multiverse, that our universe is just one of countless other universes, perhaps with different physical laws and constants. These are speculative ideas, but they highlight how much we still have to learn about the ultimate reality. Section 9. The Endless Quest, Wonder and Discovery. The universe, in its almost incomprehensible vastness, is a source of endless wonder and profound. From our small, fragile planet Earth, we gaze out into the cosmic ocean. We strive to understand our origins, our place, and our destiny within this grand, unfolding drama. This innate curiosity, this drive to explore and comprehend, is a fundamental characteristic of the human spirit. It has propelled our science and our philosophy for millennia. Every new discovery, every more powerful telescope, every ingenious experiment peels back another layer of the cosmic onion. We learn more about distant galaxies, the early universe, the nature of black holes, and the possibility of planets around other stars. Yet each new answer often uncovers a host of new, deeper questions. The more we learn, the more we realize the true extent of our ignorance. This is not a cause for despair, but rather the very essence and excitement of the scientific endeavor. The sheer scale of the cosmos can certainly make us feel small, even insignificant. And in a purely physical sense, we are. But this smallness can also be a source of profound awe and humility. It connects us to something far larger than ourselves. We are, as Carl Sagan famously said, star stuff. The atoms that make up our bodies were forged in the hearts of ancient dying stars. Our ability to contemplate the universe, to ask these questions, is a remarkable testament to the power of the human mind. The universe beckons us. It challenges us to be curious, to be bold, to keep searching. The journey to understand the cosmos is far from complete. Indeed, it may be an infinite one. It is an ongoing adventure, a testament to our species' relentless desire to know. As we continue to explore the vastness of space and time, we are not just learning about the universe, we are also learning more about ourselves and our potential. What other marvels and mysteries await our discovery in the great dark expanse? The quest continues.